For number 6, this is the big trapezoidal Riemann sum problem, and given the table that it shows, I'm going to split screen and show this table. It shows a table with values, and it says n equals 12 and the time is 60, so this is 5-minute increments. This would be so much easier if it showed it on a graph, but it doesn't. It just gives a table of values. I know that when, if I were to kind of start to graph it, I would have 0, 58, 5, 60, and 10, 65 as possible data points. But I'm only doing this so I can just kind of show the setup of a single trapezoid, that I get a trapezoid looking like this. And the area of a trapezoid has always been 1/2 the base 1 plus base 2 times height. In essence, it's the average of the two bases times the height. When you're doing a lot of these and you're summing them up, we tend to factor out the 1/2 and the height. Now, the height of this thing turned on its side is that 5-minute increment, because if this is a data point of 0 minutes, 5 minutes, 10 minutes, then the height is going to be this thing here. So that's going to be a height of 5. Then the base 1 plus base 2 ends up just being the y values that this problem spits out for these different things. So the y values are 58 plus 60. Then you do the next slide over. So you're going to do 60 plus 65 for the next one. And then you're going to do the next bit, 65 plus 64, and so on, until you hit the last one, which is only added once. So what you end up with is 1/2 times 5 times 58 plus 2 times each of the middle ones, so 2 times 60 plus 65 plus 64 plus 58 plus 57 plus 55 plus another 55 plus 59 plus 60 plus 60 plus 63. Then we close off the parentheses and we add that final 63 as a singleton. And this should give you the entire sum. Now, to answer the question about getting 7165, 7165 is exactly twice the amount that you're supposed to get. This is supposed to be equal to 3582.5 gallons. So what probably happened in this work up here that I'm seeing is that this 1/2 was missing. So that would make sense there.